Okay. Okay, I cannot do it directly in the chat, but I can then generate a link and provide you. Okay. Okay, I'm generating a link. I will put in the chat. Okay, manage access. Okay. Okay, so let's go back to the chat. There is the file. Could you please try to open it? Please let me know if you are able to open it or if you have some issue. This is a compressed zip file. Okay. So then what you can do, I will provide you also this link of the annotation tool. So you can also try it yourself. Let me open here. So this is the link of the CVAT. Then you should go in try for free. And then you follow the steps here in this slide. Okay. Any doubt you can write in the chat, or maybe you can unmute yourself and ask me if you are having issues or if you can perform it correctly. Yeah, this annotation task is something that takes a lot of time. So now we have a set of 6 images, so we can do it really quick. But if you have many images, you will have many annotations to do, and this is a work that can consume really a lot of time, and it's a very important part of the work, because to use it in for the artificial intelligence network, we should have this part well done. So it's a job that must be done. Yeah, and in some cases we have data sets that have 10,000 images, something like that. These are months of work doing this kind of annotations. Yeah. So then I would like to ask if you are doing fine following these steps here. You don't have to try all the 6 images. You can try one of 2 just to get used to the tool, how to use and how it works. And then you will be ready to start doing annotations, and you can use for your work in the future in the field you want. This works for everything, not only for defect detections. It works for many different things. Yeah. So you can detect persons, cars, and one curiosity that is starting to happen is um, some governments are starting to use this YOLO uh, uh, at the roads or on the streets of the cities, and they put special lens as a polarizer to avoid these reflections from the glass of the cars to be able to see inside. And they can see the person, and they can see if the person has a mobile in the hand. And also in the image, you have the information of the numbers of the car, so you can get at your home then uh, a bill to pay because you were with a cell phone on transit. This is one application that is starting to be implemented. Yeah, maybe in the near future it should also come here. Yeah. So everything working so far. In the next step, you will see that this is very powerful tool. This YOLO. This is really, really powerful. Okay. Did anyone manage to do at least one annotation, at least one bounding box with the data set that I have provided? Okay. I think if no one says anything, I think we can continue with the demonstration. This was, or you need some more time, please let me know in the chat if you need a few minutes more. If that's the case, if not, I will continue to the next step, which is to use this data in an algorithm. Okay, I think I can continue. So then let's continue here. The next step, I recommend you to install this Anaconda Navigator for the programming, okay? And from here, you can create your environments and you can work with your codes. I always like to, when I'm in Anaconda, to work directly in the CMD prompt command, and that's what I'm going to do. I'll open here. Okay. Now we have this command line. I hope you can see it. Okay. Then, as you see, I am in the base of my computer, but I want to go to some environment. And I have created one environment specific for this YOLO. And then we are going to activate this environment. Then you can do like this. So you use the command conda activate CV1. CV1 is the name of the environment I have created for this project. Okay, activate. Okay, it was not complete. I put active instead of activate. Now we have the environment activated. As you can see here, instead of base now is CV1. And I will use here for didactic purpose the Jupyter Notebook. This is a very user-friendly um, tool to work with Python. Okay, then let's import it. Jupyter Notebook. So it's loading the Jupyter Notebook. Okay. Okay, just a moment. Let's open the other screen. Okay, here I have the Jupyter Notebook. And then I will create here a new file. So let's create here. Here are some environments I have. As you can see, I will use the CV1 for this Jupyter Notebook. Okay. And then we will start coding. Okay. Just a moment. So what you can see here is the screen for that you can start coding your Python. And we will start importing the YOLO network. And where can you find this information? This information you can find in the website of this Ultralytics, which is the library where you can find the YOLO. And here you have all the guide how to start using this algorithm. Okay, and they have also in the GitHub repository information about this algorithm, and you can access also the structure of the algorithm here in the folder Ultralytics. You can have access to all the codes, and you can change and adapt for what you want. So, as I was explaining during the presentation, there are different models for this YOLO V8. You can see here in these graphs the nano, small, medium, large, and extra large. And here you can see the amount of parameters. And here you have other YOLO versions and a comparison of how the validation works here in this case. So it's outperforming all the previous versions. And also in terms of speed, it's also being outperform the other models. Okay, and let's go to the usage of this network. In your environment, once you create it, you have to install the library using this command. Okay, and then to start coding in Python, you will need this information here in this block. Okay, let me copy it. And let's return to the script. Okay, we have it here copied, but I like to do it separately, cell by cell. And I press here Shift Enter to load the YOLO model from the Ultralytics library. You can see here, okay, it's loaded, the model. Now, what we are going to do is to build a model from scratch. Here, I will add here a new cell. And we just load the model. Okay, here we are using the V8 Nano, which is the lightest one. It will be the faster. If you need more accurate results, you should go upper, like the small, medium, large, or extra large. Okay, but for this training, we will use the lightest one. Okay, so this essay was run now. And okay, one important thing that we will come to train the model. Okay, this we will not use because we don't have a trained model. This we remove. And to use the model, we have here, we will need just this first line for the training. And the only thing we should take care about is this file here. If you remember, I showed in the presentation this YAML file. Let me go back. This is the only thing we should take care about. Is this configuration file? Is a human readable configuration file, okay? And we need to have in this file the information of the path where the data is, okay? And this is what we are going to change, because by default, it is using this Coco dataset YAM, and we will change it to our own file, okay? Let me go to this folder. Okay. So if you see here, I have this file, okay, config yum file, and if I open it, you will see that we have exactly the information that we saw in the slide before. So we have here the path, and the train set is for the train, and the validation date is in the val folder. So let's see in this folder here if everything is fine. So we are demo training data. Data is here. Then we have images. Images here, and inside images we have the train folder and we have the validation folder. Okay, so we have here images for training the model of defects, processing pores. Okay, and the validation folder, we have other different pictures to validate the model. Okay, they are only images. And this folder should follow this configuration. This is a must. This is a requirement from the tool, the YOLO, okay? And you should also add a folder with the labels that we have done using the CVAT annotation tool. So here, it will follow the same structure. We will have a folder for the training, and here are the files for the training. So if you open, you will see the data, and it should process the files with the same name of the images that we have in the image folder. And the same thing for the validation folder. We should have the same name for the files that we have in the image folders. So this is a must. This is a requirement. If you don't do that, the training will not work. Okay. So this is, I think, is the only thing that could make the training tricky if you are not familiar with this. Okay, but otherwise everything is straight, and you can perform the training. Okay, so then I will change this, not this, the other one, this name Coco128 to config. Here, config YAML file. Then I'll just put here config. Okay. Now we have here set 3 epochs. This is the number of times that we have to loop for the trainings. And if we want, we can increase it, or we can put less. There's no sense. Just to have an idea how it works, I will let here 3. Okay, and then we can start training the model. Since this is a demonstration, I think it should be fine. For real training, I would not use only 3. I would use much more, 100, 200. So, but this is computational expensive. More epochs you put here, more time you will need to have your model trained. Okay, so let's give a try. So it's working. The model is training. So you are here with me training an artificial intelligence model for defect detection, okay? In this case, pores in images of pores where defects pores. You can here follow the progress of the training. We are here in the epoch 1 of 3. Okay, so we have to wait until the training is completed. The idea is that after every epoch, the loss should decrease. Sometimes could increase a bit. That means the parameters that the model chose was not so good. The next time it will try different parameters, and it will try to decrease the loss during the training. Okay, now we are in the second epoch of the training. You see here, I'm using here a local host. That means it's my computer that is performing this training. But you could do that using servers with GPU cards that would accelerate this process in magnificent manner. You don't have to wait so much as we are waiting here. This is actually not too much, but imagine if I had to wait here to do it 200 times. And the computer is being used, and to do other things, it requires much memory to be not possible to do. Okay, it depends also the computer you have. Okay, so we are approaching to the end of this short training. So here says the time that was concluded. Okay, then the code is finishing itself here. Okay. Then after you train it, you will get in your folder. I will share with you. Just a moment. You will get the runs. This is a new folder that is created. Detect, and you have a training set. But this is what we just did now, okay? And you can analyze the results. But as I told you, we did this just for test. It was not enough for the model to train reliable, and we cannot analyze this here. But I have done previously one test with more data. Okay, just let me find here, and more epochs, and I can show it you how does it look like. Okay, here, let me check. I think this one, yeah. Yes, exactly. So in this one, it was trained by 100 epochs, okay? And we can see the metrics of the result. We get this kind of metrics. Important thing, the loss. You should look at the loss here. Should always go down. If it's go up, something is very wrong to your model. So this is the first thing you should look at. Okay, at the loss function. It should always go down. Okay, and other kind of interesting metric that it gives is this F1 curve. Okay, and then we can use it where the model had the best performance is the peak. Okay, and we have the highest peak of confidence with this value here is around 0.3, more or less. Yeah, a bit less. And we can use this information to optimize our model. And how? And for example, when we are defining the model, here we have the epochs. Okay, we could add here, now that we know this information, the parameter conf equal to 0.3, more or less, what we saw. And to make it visible, more visible in a better way, we can do like this. And how I know this information? So if you go to the documentation of the YOLO, okay, you can find this information. Just let me look for the documentation. It's here. Yeah, so here's the documentation. And done. You can find it, guides, models, modes,